The test is not today, rather Tuesday of next week. Let's take a few minutes and talk about the test format so that if you wanted to try to do something over the weekend to start getting ready, you have an idea of kind of what we should be narrowed down our study to. So what I have written out here on the content library in OneNote is the test format. Again, you can write this down if you want, but it's in the content library, so I don't know that it's really necessary, but whatever works for you. So you have one question converting degrees to radians, one question converting radians to degrees. You'll have one calculation of arc lengths question where I'm not going to give you the arc length formula, so that's something that you'll want to make sure that you have committed to memory. One question where we're asking to find the perimeter of a sector. One question where we're solving a right triangle, so finding all the side lengths and angle measures. So again, you'll need to have SOHCAHTOA kind of committed to memory for that. I suspect we probably already have that. One question where I give you some standard position angle measures and ask you to draw the angle just on the XY axis, kind of like we did on the homework quiz. Two questions where I ask you to find the exact value of a trig function using the unit circle. I would provide you the unit circle. That's not something you need to have memorized, although you would need the unit circle definitions of sine, cosine, and tangent, etc. So like that sine is y and cosine is x and all that jazz. You'll have one question where I give you a point on the terminal side of an angle and ask you to write the 6 trig ratios. So again, for that, you'd need to have memorized the point on a terminal side definition for sine, cosine, and tangent. So like x over r, y over r, yada, yada, yada. You'd need to have those memorized. Would not be provided. But again, all those definitions are kind of just SOHCAHTOA, right? So they're kind of, we already know them. You'll have one question where I give you one of the ratios and the sign of another and ask you to find a third, one of the other 4 remaining ratios. Like we did a bunch of questions like this in the homework and on the worksheets. You should be able to use the unit circle to evaluate an expression. So I think we had some questions like this on the review where it'd be like, sine of 210 times cosine of 45 plus tangent of 330, something, something like that. And then the last 2 questions are kind of on the transformation topics again. So one question, I'll give you a parent function and the transform function and ask you to just describe the transformation. So identify the A, C, H, and K, and then write down the stuff in order. Like we did on, I think, worksheet 2 has questions like that on it. And then one question where we give you a parent function and several transformations and ask you to find the final transform function. Again, I think there were several questions like that on worksheet 2. Hi. Thank you. Sydney Meyer. Looks like you're leaving here in a few minutes. Oh, not in a few minutes. In several minutes. You're welcome. So hopefully that narrows down a little bit kind of what you need to review. Notice that not everything on this list was on the review, or not everything on the review is on this list. And I think there might be some of these transformation topics. I can't remember if I put those on the review when I initially wrote it or not. So be cautious of that when you're getting ready to prepare, but this list here should help at least narrow down a little bit on what you need to kind of look over. Clarifications here. Amy?
Could you just repeat again what we need to have memorized?
Sure. So the things that you'd want to have memorized are your arc length formula. So like S equals R theta, and then the degrees version of that. You would need to know the conversion factors from degrees to radians and radians to degrees. And then you'd want to have your 3 different definitions for sine, cosine, tangent, etc. So like one of them is SOHCAHTOA, that's the right triangle definition. The other is the point on the terminal side of a standard position angle definition, so that's like x over r, y over r, etc. And the third is the unit circle definition. So that's like cosine is x, sine is y, tangent is y over x, etc. And I think those would be the things that you'd need. Now, those three sine, cosine, and tangent definitions are all basically just SOHCAHTOA, right? It's just a slightly different interpretation, but Aiden.
On the test, like the unit circle you give us, is it going to be filled out or do we have to fill it out?
No, it's going to be like the printout version that I put on the, it'll be exactly this.
Okay.
It'll be exactly this one. So that will be given to you. So no, you don't need to know have it memorized or to fill it out. That's more time than I'd want to spend on something that's not a particularly difficult exercise, but can be a time-consuming one. So, okay. Does that help narrow things down as far as studying purposes go? I hope, right? Like, try to get a better picture of what exactly you need to do. At this point, I'd like to take a little bit of time. Last time you guys spent the entire class working on your problem sets, so I imagine that some of us have a few questions on things. You can be super specific, like a problem number, or it can be like kind of general, as in like, hey, I was doing this kind of thing and I don't understand what's going on. But let's take a few minutes here and deal with some of that. Jack, we'll start with you.
Do number 57.
From the problem set?
Yeah,
sure. Let me just make sure I grab it. So that page will do. Okay. So it says find the exact value for this using the unit circle. So straight away I noticed that 330 is a unit circle angle, so I don't have any adjusting to do. So I'm going to just locate 330 on my unit circle. And I know that cotangent is x over y. So I'm going to go to my unit circle and take my x coordinate. And the denominator is going to be the y coordinate. So far, so good. And now I'm just going to simplify. So dividing fractions is easy as pi. Flip the right and multiply. So the 2's cancel out, and I'm left with just negative root 3. Is that okay, Jack?
So you just multiply by the reciprocal of negative 1/2.
Exactly, yes. So to divide two fractions, you multiply by the reciprocal of the divisor. In the case of the way we wrote it there is a big fraction, it'd be the reciprocal of the denominator. Sergio?
You simplified that. Why did you take the 2 out of the number?
So I multiplied by the numerator times the reciprocal of the denominator. Cool? Okay. Lexi?
50.
Okay. Are we cool with this one before we move on for the next question? Amy?
So I just have a question. Cotangent is x over y, and then would tangent just be y over x?
Correct. Yes, that is correct. And those definitions are in the notes from 920. Right, we have them. Those are the unit circle ones, and then up here further we have the standard position angle ones. So on 920 notes, we have all those things written also. You're welcome. Okay, you said 50, Lexi?
Yeah.
Okay. So here we're just asked to determine whether things are positive, negative, depending on this range of values for theta. So 50 is what you asked about, right?
Yeah.
Okay. So I'm going to start by just figuring out which quadrant is 4 pi and 9 to 2. Yeah. Which quadrant contains the angle measures from 4 pi to 9 over 2 pi. So I remember that my quadrants are all 90 degrees, right? Etc., right? Now, if I convert 90 degrees to radians, that's that. So if I'm going to 4 pi, that's half, 1, 1.5, 2, 2.5, 3, 3.5, 4. So starting here to 4.5. So I'm really just worried about quadrant 1. Okay with that? Now I know that sine is y, cosine is x, and tangent is y over x. In quadrant 1, both x and y are positive. So here all of them are positive. Is that okay? Luke. No, Zach. Sorry.
I kind of got lost when you did the spiral thing. How did you know to go around that many times?
So I'm just counting. So I'm trying to figure out where 4 pi starts and where 9 over 2 pi ends. Okay with that plan?
Mm-hmm.
So I'm starting at 0 pi here. And then to here is a half a pi. 1, 1.5, 2, and then I just keep going. So 2.5, 3, 3.5, 4, that's where I'm started. And then to 4.5. So I'm just kind of counting around.
That's a pi. 4.5.
Yeah.
Okay.
9 over 2 is 4.5, right?
Yeah, it's like 8, 10 degrees or something.
Sure. I didn't convert it, I just counted.
Yeah, it is.
But that's all I'm really trying to do. Does that feel okay? Now you could convert this into like, the other option you could do is you can say, okay, what if I wanted to just find something coterminal? I mean, you could just subtract 2 pi from each end until you get something that shows up on the unit circle. You could do it that way also, depending on whether you want to do it like computationally or visually, whichever works better for you. But if we subtract 2 pi from both ends twice, you end up 0 to pi over 2, which is also quadrant 1. And you may draw the same conclusion without having to draw the picture.
How'd you get sine 70 cosine 10?
Those are greater than 0.
Oh. Whoops.
That's okay. I try to, my 7s, I'm always going to put a bar on there because they're, again, my penmanship stinks.
Okay.
But if the bar is in there, it's a 7. If there's no bar, it's something else.
Okay.
Edmund, is it follow-up to this question or something new?
It's
Okay. Amy, is follow-up to this one or something new? Okay. Edmund, let's go with you.
Can you do 13 on worksheet 1?
Sure. Sheet 1. Okay. So the first thing I'm going to want to try to do is figure out which quadrant to draw my reference triangle. So cotangent I know is x over y. So I need either x is equal to -4 and y is +3, or x could be +4 and y could be -3, right? Here we're told that sine is negative and sine is y. So I know the situation I want is the one where x is positive and the y is negative because, well, the y has to be negative. Cool so far?
I put y over r when evaluating, so that's where I think I messed up.
Yeah, so use the unit circle
I see.
definition. I mean, r is 1, but,
I see.
well, we're going to abandon that actually quickly, but the r is always positive. You can, so that,
So in all these examples, you wouldn't have to evaluate with y over r when you're
well, eventually we'll probably need r
Okay.
because we're probably not going to find the unit circle coordinate. But r is always positive, and that alone is enough
To complete.
to complete which quadrant it's in, right? Because remember that what these things are representing, x and y is the coordinate of the point on the terminal side, and r is the distance from that terminal point back to the origin. So that distance is always a positive. The x and y can be negative because they're coordinates. So we have this situation. So my point is 4, -3. So if I make my reference triangle, should be easy to see that r has to be 5, right? The Pythagorean Theorem gets me r is 5. So then cosecant is r over y. So that's just 5 over -3. So hopefully what you're seeing as we're doing these things is that none of these, the arithmetic is terribly complicated, or the algebra is terribly complicated. It's about how well you can move in between your definitions of like sine, cosine, and tangent, and when you know like which is the appropriate definition for which spot. And like making sure that you're using the geometric ideas to determine the signs on these things. And so that's where the complication lies. It's the computation part is not difficult, but like the setup and like using these definitions tends to be the more difficult part. Knowing what to do, not really how to do it. You know what I mean? Is this a follow-up to this question, Natalie? Something new? I'm gonna go Amy and then come back to you then.
Okay.
Amy, what's up?
Could you do an example using the unit circle, but the value is not on the unit circle?
Well, that you can't.
Well, like, one over here, it says like the cosecant of 390 degrees.
Oh, sure.
Like 1 times.
What number is that?
It was in the examples that we did for the day.
Oh, okay.
58 is
58. That'll work, right, Amy? Okay. So 480 obviously is not on the unit circle. Although it says to use the unit circle to do this, so all I'm going to do is find something coterminal to 480. So I'll just like subtract 360 from that. So that's the same thing as cosine 120. Cosine 120 is just x. So 120 degrees. The x coordinate is 1/2. And I'm done. Alternatively, if you prefer, you can do like just finding it visually. So like 90, 180, 270, 360, 450, and then 30 more gets us right here, is the same thing as 480. So you could do it visually also. And you just, again, pull the x coordinate then. So either way of kind of thinking about it, whether you want to find the coterminal thing computationally or you just want to go spinning around the unit circle and find it visually, either is okay. Cosine is the x coordinate at 120. So I found 120 degrees and pulled the x coordinate. Because cosine theta is x on the unit circle. Natalie.
It's on worksheet 2, number 8.
Okie dokie. Okay. So horizontal shrink by 1/4 tells me C is 1/4. Yes. Vertical stretch by, I'm going to write this down over here. Vertical stretch by 3/2 tells me the A is 3/2. Vertical shift by -3 tells me k is -3. And reflecting over the x-axis tells me a is -1. Are you okay with that much, Natalie? Okay. So my first one, g of x, is going to be 1 over c times x. Oh, this is how I want to write f of x. Sorry. So far, so good. Okay, and my f of x in this case is 2x squared minus 3x plus 1. Oops. So that's going to be 32x squared minus 12x plus 1. So b then is going to be 3 over 2 times that previous answer so let's see, that's 16 times 3, that's 48, right? Yes.
But don't you do it in the right order?
Well, the directions say
Oh,
in the order indicated below. So the directions here are telling us to do it in this order that they're listed. So, but that's a good question. 18, and I'm just going to write as 1.5 instead of 3 over 2. Is that okay? Okay. And then for the next step, that's going to be the previous answer minus 3. So 1.5 minus 3 is just negative 1.5. And then the last one is going to just be the -1 times the previous. So we flip the signs.
Okay.
Does that feel okay?
Yeah, I did the entire thing wrong. I'm like, nope, scratch that.
Okay. So again, the key here is you're just using our general transformation, right? Where everything is null except for the one thing that we're doing.
Thank you.
Yep. Mia?
In the chapter 2 review, you use question 8, A.
What page is that on? Do you have it right?
6.
6. Perfect. Okay. So 8A, you say?
Yes, please.
Okay. So it's wanting us to do this using I would do this using the unit circle. It just says to find the exact value, but I noticed that the denominator is 1, 2, 3, 4, or 6. It's going to be a unit circle value for radians. Since the denominator is 3, I'm good with that. if I'm going to do this visually, I notice that this is like 3 2/3. If I'm just converting 11/3 to a fraction. So if I'm going to do this visually, half, 1, 1.5, 2, 2.5, 3, and then 1/3 to here, and then 2/3 to there. So that's my coterminal angle. And since we're doing sine, I just want the y coordinate.
Yeah, so I didn't use the unit circle, so I got this really weird denominator under a square root, and I was like, how do I simplify this?
Yeah. Again, you could have also subtracted 2 pi from this, and that would also have given you the 5 pi over 3.
Yeah, that's what I did.
And then you go to just go to the 5 pi over 3 and pull the y coordinate. That would be fine also. Drake, what's up?
First question, what does this say up top in the top left?
So the negative root 3 over 2 or the 3 2/3 pi?
No, this is actually for the review. I think they're
Okay.
no, it is worksheet 1. So like, for example, like number 13 or 14, between like 13, 14, 15, how would you determine that which of the numbers were the negative?
So on like 13, I didn't know. I knew that just either x was negative or that the y was negative, but not both at the same time. So I started off with both of them being a possibility, but because sine is negative, I know sine is the y. So I knew it had to be the one where the y coordinate was negative.
Okay.
So just from the cotangent, I didn't know one of these two situations, it's either x was negative, y was positive, or x was positive and y was negative. But the sign being less than 0 tells me the y must be negative. So it had to be that situation.
So for example, tangent, like you have that number, tangent is less than 0. It would...
So if tangent is less than 0, it tells you either y is negative and x is positive, or x is positive and y is negative. If this question was cotangent and then tangent less than 0, there's not enough information for you to know which answer it is. Jack?
You do 59 on the
Sure. So same kind of question we're just looking at there. So I know cosine is x over r. So I know x is 2 and r is 3. And I know cotangent is x over y. So I know that this is 2 over y. And I know cotangent is negative. So it tells me the y has to be negative. Is that okay there? So I know I'm going to be operating in the fourth quadrant where the x is positive, but the y is negative. So I can then use the Pythagorean theorem to find that y coordinate. So that's going to give me the square root of 5. So once I have that, I can say, oh wait, man, which one am I looking at? Okay. Find sine, oh, it says find sine and tangent, okay. So sine is y over r. And tangent is y over x. Okay with that? Again, remember the sides of that triangle represent the coordinates of a point on the terminal side of our angle, right? So the horizontal side is our x coordinate, the vertical side is our y coordinate. Does that feel okay, Jack?
Yep.
Okay. Sorry, I had to try to squeeze that in there as I wrote too much for the other ones, I think. Follow up to this one.
This is a follow-up to the one that Mia asked from the review.
Okay.
So when you took the 3 out of the 11 pi, that was just because you just reduced, correct?
I just wrote it as a mixed number instead of a improper fraction.
Okay, and you got the 3 from taking it out of the 11?
So like to turn this into a mixed number,
Okay.
I did like my long division. So that's 3 2/3,
Okay.
like just like we did in elementary school.
Yeah.
Okay.
Thank you.
Yep, no problem. Natalie, did you have a question?
Yeah, it's worksheet 1, number 5.
Okay, do I have that up?
We know, I think we already put that.
We did worksheet. We don't have the first page of it though, I don't think.
We already did this.
Did we already do this worksheet?
Yeah, I think we did.
I don't think.
That was the other.
Yeah, I think we just got the second. I just pulled the second page, I think, from it. But I will take the unit circle. Okay, so number, which one?
5, I think we already did something similar to it.
We have done something similar to it, but that's fine. We can do this again.
Can we do that again?
Sure. So again, what I notice is 810 is not a unit circle angle measure. So I'm going to find something coterminal to it. I can either do that numerically or I can do it visually. It doesn't really matter. So numerically, I'm going to take the 810 and I'm just going to keep subtracting 360 from it until I get a number between 0 and 360, because those are my unit circle values. So that's the same thing as 90. You good with that? Alternatively, I could go visually on my unit circle. So 90, 180, 270, 360, 450, 540, 630, 720, 810. Puts me back at the same spot at 90 degrees. Now I know that tangent is y over x. So that's going to be 1 over 0, which is undefined. Cool?
Wait. Did you get when you did the unit circle? Missed that part.
So I did tangent is y over x, right? So y coordinate is 1, x coordinate is 0 at 90 degrees. So I just have 1 over 0, or undefined. Is that good, Drake?
Yeah.
Okay. Who is next? Zach?
So I can tell that like the degrees numbers are just around the unit circle, and then the radians is the version of that. How did you get those numbers in parentheses?
Those numbers in parentheses. The 90 degrees?
No, in the unit circle, past the degrees and the radians, whatever the x and the y is, like where did you get those numbers from? Because I know what they are, I just don't understand like how they play in there.
So we defined last time, we started off with like SOHCAHTOA, right? Mm-hmm. And we said, okay, let's take SOHCAHTOA and apply it to an angle in standard position. So I can take like this, I can make a triangle when I pick some point on that terminal side. One side is the x-coordinate, the other side is the y-coordinate, and then the hypotenuse is going to be the distance from that point to the origin. So using sine, cosine, and tangent SOHCAHTOA definitions, I can say like sine is opposite over hypotenuse, etc., etc., etc. Using the same SOHCAHTOA definitions, I get this. And then I say, okay, well, here I just picked P to be arbitrarily anywhere on that terminal side. What if I standardize it so that when I pick that P, it's always 1 unit from the origin? In that case, all of these R's just become 1. So on my unit circle, these points that you're seeing is cosine theta and sine theta. Because sine was y over r, but r drops down to 1. So the coordinates on the unit circle are actually the values of sine and cosine at that value of theta.
Okay.
So like cosine of 90 is just going to be the x-coordinate. So it just, this is where we built to. Is that what you're asking?
Yeah, that makes sense.
Okay. So the big takeaway is that these points on the unit circle are now the same thing as the values for sine and cosine at that angle measure.
Okay.
Okay. What else? Zach?
What was number 60 on the, can you do number 60 on the homework?
Sure. So I know that sine is y over r. And I know that y is representing an x or y coordinate, but r is representing the distance from that point to the origin. So the r has to be positive, so I know that y is negative. It can't have a negative r. And we're told that cosine is negative, but cosine is x. So I know the x-coordinate's negative. So the place that I'm working in has to be in the third quadrant, where the x and y are both negative. So far, so good?
Mm-hmm.
So I can do the Pythagorean theorem to find this third side length. So 4 squared equals negative 1 squared plus x squared. So that's just going to be the square root of 15. And now I have everything I need to answer the question, which was secant and cotangent. So secant theta is 1 over x. And when I rationalize the denominator then, it's negative root 15 over 15. And cotangent theta is x over y. Now let's just write x over y, and there's nothing more I need to do to that one. Okay with that?
Yeah.
So, before the test, you definitely want to make sure that you have memorized these like 3 different versions, the 3 different definitions for sine, cosine, tangent, etc. Like, life will be much, much faster and go much easier if you have those 3 sets of definitions kind of committed to memory. And now remember, they're all kind of the same definition, right? To go from SOHCAHTOA to the standard form angle definition, you just replace opposite with y, adjacent with x, and hypotenuse with r. Easy. If you know SOHCAHTOA already, it's just 3 other things to remember. And then to go from the standard position angle to the unit circle definition, you're just replacing the r's with 1. So like y over r becomes y. X over r becomes x, etc. And that's it. So it's really not much to memorize, because if you know SOHCAHTOA, you kind of know all the other ones already. But you do need to make sure that you know that stuff. When we come back from lunch here in a minute, we'll go straight into this homework quiz and knock that thing out, and you guys can take the remainder of your time to work on your problem sets. Okay?
You didn't have to do it, but then okay.
Yeah.
It's all one of that
Look,
problem.
look, all you guys belly ached about the first homework quiz because it was like, I haven't gotten a chance to do the homework yet. So I intentionally waited to do another one until you've had I gave you 80 minutes to work on the homework. But I gave you 80 minutes yesterday to work on the homework. 80 minutes.
There's a lot of homework for this week. Yeah, we didn't have.
I actively chose to do the stuff that was due like for other classes.
Well, you know, like,
I was doing that. I just didn't finish it.
well, that's okay. I'm sure you've done enough to what I'm going to ask you about.
What's game?
Yeah.
to go.
Is the homework quiz just like reading them?
I say we should be able to.
Pretty much.
It's going to be pretty much.
Okay, I can do that.
If you can do the problems that we were doing here, you're going to be in fine shape.
When does this lunch end?
It ends at 1:10.
Okay, so I won't be here because I'm leaving at 1:05.
Okay.
So,
Next week during community time?
yeah, can I just email you like what day
Absolutely.
works? Because I think I have a meeting during community time.
Yeah, you don't even have to know now. You can just email me the day that you're planning on coming. It's not a big deal. It doesn't require any kind of pre-planning on my part. So
Okay, thank
you
you.
should be good.
I'm just go with just one little quick fix up if that's cool.
Sure.
So for number I missed it. Number 4. So I get it's not number 2. Sorry,
Okay.
number 2. So I get how you got this. You just kept on adding 2 pi's until you got this. In this case, it was only 1 2 pi.
Right.
So I get that, and the only thing I was confused about is how you got 2 over the square root of 3.
So I have 1 over cosine is the same thing as secant,
Yeah,
right?
well,
The reciprocals.
What? Yeah. Oh. Okay.
Is that cool?
I thought so. Secant is the opposite of cosine. So
Yes.
so it's 1 over x.
It's
in this case.
the
Yeah.
reciprocal of cosine. So that's I just wrote as 1 over cosine, which is 1 over x still.
Oh.
Right?
Okay.
So that's all I've written here. And so what I did is I found the x coordinate on the unit circle, which is root 3 over 2, and I just made the reciprocal of it without showing.
Oh, I see. So it's
So
it's not 1 over root 3 over 2.
Yes, that's the same thing as 2 root 3.
It is.
Yes.
So
Would you like
1
to see
over-
how?
Sure.
Okay.
Root 3 over 2. 1
Over
root 3 over 2. This is the same thing as the answer.
Yes.
Okay, so I was just confused. I guess algebraic
So,
in
like-
that sense.
I'm going to just take the numerator and multiply it by the reciprocal of the denominator, which is just that.
Gotcha.
And then I rationalize that.
I just didn't get the algebraic explaining it again. Got it.
No problem.
Appreciate that.
Sure.
All right.